Hello and good morning. CTS265 Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP route course for version 7. And we're going to be taking a look in our video tutorial today of Challenge Activity 5, which you should have completed this week. All right, so here is our solution set for Challenge Activity 5. We're going to configure OSPF. As you can see, we don't get a whole lot of detail here. It says the customer expects that you will implement OSPF according to the network topology design created by its internal networking team. Before you start the configuration, you're told that the customer also wants you to harden OSPF on the HQ1 router by configuring passive interfaces. So it's interesting they use the word harden because that's typically a security keyword where maybe we would set up authentication between the HQ router and the distro and maybe HQ2, but they're talking about it in more of an optimization phase where we're going to set some interfaces to passive. You also need to make sure that the router DIST does not actively participate in the OSPF elections on broadcast segments, but they don't tell you which elections. So but what they're talking about, right, is if it's on a broadcast segment, what is going to be the election that takes place? You've got it. It's going to be the DR or the BDR. And so again, customer expects you to implement OSPF according to topology design. So let's go ahead and dive in here. And we've got some external networks here that are probably, if they're not already being redistributed, will be. So we'll start on the HQ router because we want to make sure, or actually I apologize, the dist router, because we're going to make sure one of the first things we do is that the dist router, because that's kind of the low-hanging fruit in this activity, is that we want to make sure that the dist router show run section OSPF. And there's no OSPF section at all. So we want to make sure that the dist router does not actively participate in the OSPF elections on broadcast segments. Well, what are the broadcast segments? They're going to be Ethernet 00 and Ethernet 01. So we're going to go ahead, and they don't give us any area breakdowns here in terms of activating OSPF. It doesn't say. Let's see. See if the job aids give us anything here. Ah, there we go. Okay. All right, so we're going to be looking at area 0 here. So dist appears that all of its interfaces are going to be in area 1. So let's go ahead and fire up OSPF here on the dist router. And we're actually going to use that shortcut that we saw earlier. So we'll go in the global config. I'll say router OSPF, and I'll say we'll just use 1 for the process ID. Again, remember, it's locally significant. Now, we want to have OSPF running on all 3 of the interfaces, ETH0, ETH01, and the loopback address. So now there's a couple ways that we could approach this. We can simply say network 0.0.0.0.0, and then put in the wildcard mask of all 255s, which means I don't care what we match, area 1. And so that should take care of the dist router OSPF setup. Now remember, sort of the low-hanging fruit that we were looking at was on broadcast segments. Well, if I were to say do show IP OSPF interface and take a look at what my broadcast segments are, well, the loopback interface is not. It's a loopback. But what are the broadcast network types? Ethernet 00 and Ethernet. Whoops, and we're still going there. Hold on. So that was Ethernet 01, I guess it was first there. Did I miss that? Yeah, Ethernet 01 is broadcast, and Ethernet 00 is broadcast. So if we don't want those guys to participate, let's go into Ethernet 00. We're going to say IP OSPF priority 0. And that is going to make these guys not participate in the election on 00 interface Ethernet 01. We're going to use that same command because, again, when we set the priority to 0, we're saying do not participate in any of the DR, BDR election activities that are going to take place. All right, so now that we've got this, let's go ahead and see. Let me take a look one more time at this scenario. Let's see. So we've got the... Also need to make sure that the router dist does not actively participate. So we took care of that. The step before that says we're going to harden OSPF on the HQ1 router by configuring passive interfaces. So let's take a look at the aids again here. All right, so the HQ router. So it said HQ. It didn't say HQ 1 or 2, or did it? Let's take a look at the scenario again. Yeah, HQ1. Sorry about that. Okay, so on the HQ1 router, we want to leverage passive interfaces, and so it's got to be on that loopback interface there. So let's go ahead. Let's jump onto HQ1. Let's see what we're looking at. What are we dealing with here? So we'll go from user exec to privilege exec. I'll say show run section OSPF. All right, good. So no OSPF is running. Show IP interface brief. So we've got a loopback interface and we've got the two Ethernet interfaces. So let's do this on HQ1. For HQ1, we're going to go ahead, instead of using the network statement, we're going to use the IP OSPF process ID number and then area statements on the HQ1 router. So we'll go into global config. I'll say router OSPF 1. And I'm going to go ahead, and that's pretty much all we need to, well, actually, I guess what we should be doing here, no router IDs are getting picked up. So not that big of a deal if I were to set, let's go ahead for HQ1, we'll set it to 1.1.1.1 so that we can at least identify HQ1. And then let me go ahead and jump into interface Ethernet 00, which according to the diagram, it's going to be IP OSPF 1 area 0. I'm going to go into interface loopback 0. And I'm going to say IP OSPF 1 area 0. And then we're going to go into interface Ethernet 01. And we need to be careful here. IP OSPF 1 which area? This will be area 1. And we should have the adjacency come up between the distribution router and the HQ1 router. So do show IP OSPF neighbors. Do we have anything? And we did. So it looks like it did come up. We just didn't get a message, didn't log it to the console, and that's okay. Now, remember, we need to take advantage of the passive interface command. So router OSPF 1, I'm going to say passive interface. Now, there's a couple ways I could do this. I could say passive interface default, but that's not what we want. We simply know that loopback 0 should be passive. So if I say do show IP OSPF, and there's the message. Okay, so it just took it a while for that message to pop up. Or do show IP protocol. Sorry about that. Do show IP protocols, and we want to take a look and see how are these interfaces, how have they been enabled, and are any interfaces passive? Absolutely. So we've got the loopback 0 interface is a passive interface, and so that's good news, which means that we're not sending hellos. However, it is being advertised. So if I came over to the distribution router and said do show IP route OSPF, are we picking up that 192.168.1.1? Absolutely we are. And there it is, right? And it's an inter-area route because this is area 0 and it's coming down into area 1. So HQ1 is an ABR, and he is flooding a type 3 LSA, a summary, a topological summary LSA for 192.168.1.1. In fact, okay, so good. So it shows as a /32. Let me do this. Let's make sure that, and actually it's a /. Okay, so it is /32, so we're good. All right. So we've taken care of the H21 piece. So now we've got some other setup we need to do. Let's go ahead and jump over to HQ2. And let's go ahead and configure HQ2. We'll go from user exec to privilege exec into global config, do show IP interface brief. Let's take a look at the interface to see what we're dealing with here. Again, we've got 3 Ethernet interfaces and a loopback interface. And these guys are, we've got a hodgepodge of areas here. So let's go ahead and do this. Let's say router OSPF1. My router ID is going to be 2.2.2.2. And I'm going to go ahead, because we've got all these different areas here, let's jump into each individual interface. And I will go ahead and say, we'll start with interface Ethernet 0.0, which is going to be IP OSPF1 area 0. And then we're going to go to interface Ethernet 0.1 and say IP OSPF1 area 1. And then interface Ethernet 0.2 IP OSPF 1 area, and that is area 2. And then finally, let's pick up that loopback interface, interface loopback 0 IP OSPF 1 area 0. All right, so now if I say do show IP OSPF interface, whoops, and we'll do the brief. What do we see? Well, we've got OSPF running. We can confirm Ethernet 0.1. Yep, that's area 1. Ethernet 0.2. Yep, that's area 2. And then the loopback and Ethernet 0.0, those are both in area 0. And we see our costs, and it looks like we have got some. All right, so we see the wait time over there. I'm waiting for that final one to transition from wait to either the, yep, there it goes, so the DR, good. All right, so if I were to say do show IP OSPF neighbors, you can see that with the distro router, which has this router ID, that I have a full adjacency with that router, and his priority is 0. Remember, we set the priority of the distribution router to 0, and so he is just simply a druther or DR other. So who is the DR on, well, actually, yeah, so on the Ethernet 0, no, actually, this is reflecting area 0 here for router 1, priority of 1, right? And router 1 is the DR on that segment right there in area 0. Okay, so we've got that done on router 2. Let's go ahead now, on HQ2, I should say. Let's go ahead and did we passive that interface? Let me, on HQ, do show. It didn't ask us to optimize things. Let's see, section OSPF. Yeah, so let me say router OSPF 1, and we're going to go ahead, we'll passive that loopback interface, loopback 0. There we go. So if I say do show IP protocols, we can see that loopback 0 is a passive interface on HQ2. So we'll optimize that as well. Again, no need to have OSPF sending hellos out these loopbacks like this, right? Because do we have any OSPF speakers out here? We don't. We're going to do the same thing here on the gateway router. We'll make sure that we tighten this config up a little bit. So let's go ahead and that is the HQ router. Let's transition over here to the gateway router. And we'll go from user exec into privilege exec and into global config do show IP interface brief. And so you can see we have an internet facing address here, this 209.165.200.226. And we definitely don't want OSPF running on that, because that's our internet facing. So we're probably going to do a default gateway here as well. So let's do this. Let's say router OSPF 1. And let me set the router ID of the gateway router to, we'll just use 9.9.9.9. Something so that we can identify it. And then, let's see, how do we want to handle this? Let's go ahead, we'll mix and match on this one. So I'll use a network statement for 172.16, and actually let me check and see. Do show run interface Ethernet 0.0. Let's confirm that that is a /25. Okay, so we're going to say network 172.16.123.0. And then the subnet mask, or I'm sorry, the wildcard mask is going to be 0.0.0.127. Area 0. Is that 172.16? There it is. Yep. All right. So the Ethernet 0.0 interface, now if I say do show IP OSPF interface brief, we should see Ethernet 00 is running. He's in the wait state, and he is gone to drother, dr other, right? Okay, so we've got that Ethernet 00 interface running, and then we're going to do a mix and match here. So let's go to the loopback 0 address. I'm going to say IP OSPF1 area 0. And so now if we run that do show IP OSPF interface brief, again, you can see that we've got the loopback and the Ethernet 00 interface. Let's passive that loopback interface. So if I were to say router OSPF1, passive interface, loopback 0. Let's confirm that. So do show IP protocols. And sure enough, the loopback 0 interface is passive. Okay, so that takes care of the gateway router configuration. We've got HQ2 is configured. We did not do the branch router. So let's drop down and pull up the branch router down here. And you can see the branch router had a significant number of loopback interfaces. If we look at the diagram, you can see we've got loopback 1, 2, 3, and 4, and those appear to all be external. So let's take a look here and see what we're dealing with. So show IP interface brief, and yeah, we definitely have a significant number of loopback addresses. So we're going to passive that 192.168.5 because again, that's in the area 2. And no OSPF speakers at that link. So let's go ahead and go into global config. We'll say router OSPF1, and I'll set the router ID here on the branch to, we'll do distro, we'll change to 3333. We'll set this guy up as 4.4.4.4. And again, we can do a mix and match if we need to. So it looks like the subnetting on those loopbacks is okay. So we have .1, so .0, 128. So we've got some interesting, whoops, sorry about that, interesting loopback addresses there on that branch router. So we're going to handle this on a per interface basis, and let's go ahead and get the 172.16.25.0. So if I were to say and actually, let's do this. So let's mix it up a little bit. So I'm going to say passive interface default, right? So now that's going to make every interface on this router passive. And then what I'm going to say is no passive interface, Ethernet 00. I'm going to say no passive interface. Oh, actually, we want to leave the loopback. Yeah, so let's do that. That actually worked out well. So no passive interface, Ethernet 00, because that's the only interface on which I'm going to try to establish an OSPF adjacency. Right? Remember, we're on the branch router here, so I'm going to no passive this guy, and I'm going to passive everybody else because I need this adjacency here, so this is the only guy who should be no passive interface. And we just accomplished that there. So let's go ahead now and say, we'll go into the interface level. Interface Ethernet 00, IP OSPF1, area 2. And I should get an adjacency that forms here. Do show IP OSPF neighbor. Nothing yet. We should get an and there we go. All right, great. Went from loading to full with neighbor ID, with the router ID 2.2.2.2. We know that's HQ2, and HQ2 was elected as the DR on that broadcast segment. All right, then let me go ahead and go into interface loopback 0 and say IP OSPF1 area 2. And let's spell OSPF correct here. All right, so now if I were to say do show IP OSPF interface brief, there we go. So those are the two interfaces running OSPF. We've got the transit segment between the branch router and HQ2, and we've got the loopback interface, loopback 0, in area 2. Now, we didn't enable, do show IP interface brief, we didn't enable OSPF on these other loopbacks 1 through 4 because those are the external networks that we're going to be dealing with here. All right, so let me take a quick look at the topology. So the gateway should be good. HQ1 and HQ2 should be good. Let's see, what else? We've got the branch router, the distribution router, and we took care of the priority as well, but I thought that we would be doing a default information originate off of, and maybe it's already there. Let me check here. Let's see if I look back at the gateway router here, and let's say do show IP route. Do we have a default route? I don't see a default route there. If I come all the way down to the branch router, do we have a default route? Do show IP route? Right, so I'm picking up all the routing information I'm supposed to. It looks like we've got full connectivity. So let's do this. Can I ping? Do ping 192.168.3.3. Can I ping the loopback off of the gateway router? I can. Let me try 1.1. 192.168.1. Whoops. 1.1. So I've got full connectivity there. And what is it? 2? No, I'm 2.2. So yeah, so let's do this. It looks like that may be it. So we're going to spice this up a little bit. And let me see. Can I ping? Do ping 209.165.200.220. Or I'm sorry, 200.1. So I don't have connectivity out to the internet from the branch router. What about the distribution router? Can I ping 209.165.200.1? And I can't. And why is that? And it's interesting because I don't know. Did they ask in the scenario here? Intro networking team before you start configuration, tell the customer. Yeah, I don't see anything in the configuration here, but this is definitely begging for, and let's see, maybe it says it here. That's just kind of the aids. Yeah, so it's interesting. So we're not using these external routes for much of anything. And we don't have a default route. All right, so we're going to spice this up a little bit. Let's go ahead and try to make this a little real world. So in a scenario like this, all of these routers would want connectivity out to this 209.165.200. I'm sorry, 201. Oh, that's why. Am I pinging the wrong address? I think I'm pinging the wrong address. Let me double check this here. So it's 201.1. But again, we still don't have connectivity. If I come over here to HQ1, let's see if I ping 209.165.201.1. No, we don't have connectivity. All right, so we're going to do a default information originate statement. Because if I go to the gateway router, if I do a do show run and pipe it to include route, you can see, oh, route map uplinks. Well, this is interesting. Let's take a look here and see. So it looks like we've got a route map in here. So is there a prefix list somewhere, or is it just this? Yeah, so okay. Uplinks permit. And the route map is uplinks. And so where is that? So we've got secondary addresses on Ethernet 01. And the internet is supposed to be the 201.1. So let me see. Can I ping, do ping 209.165.201.1. All right, so I've got connectivity out to that network. So as long as traffic can get to the gateway, right, if it knows to come to the gateway, then it's going to know how to get out of the network. So let's go ahead, let's make this a little more robust. I'm going to go ahead and we're going to add in a default information statement. But before we do that, I'm going to throw in a default route. I'm going to say IP route to get to the 209.165.201.0. And is that a... So it's a /224, so it's 1, 2, 3. Okay, so it's got to be on the other side of that. So we're going to say to the 201.0, and it's going to be 255.254. And I'm just simply going to tell it, hey, go out Ethernet 01. So now I could have done the default information originate always without putting this default route in here, but we're going to go ahead and put the default route in. Let's see Do show IP route. Do we have the default route in here now? 165.201. So directly connected, right? So it shows that we have a directly connected. So now that's okay. I'm going to go ahead and we're going to go into the router OSPF 1, and I'm going to say default information. Whoops. Default information originate. Now I could put the always in here. I could put a metric. So let's throw a metric on it. So I'll say metric, and we'll make it 5,000. So default information originate metric 5,000. So now if I come down here to the branch router, let's see, did that default route make it down here? It did not. So we're not picking up an OE2 of any kind between the areas. So do I have a default route into, or let's see if what we have on the HQ routers here. Show IP route. Did I pick up an OE2? I did not. So that's interesting, and I'm wondering if that's because we've got secondary addresses on that gateway router. So let's do this. I'm going to pull this back, and we're going to say no default information originate metric, and I'm going to do the default information originate always. Let's see if that changes anything. So we'll come down here to the branch, and there we go. So the default information originate always needed to be run so that irrespective of whether the default route is there or not, and we can pull that default route out. If I go back to where I entered that default route and we say Control A, so I'll pull the default route out. It doesn't matter, right? Whether that default route is there or not, we're going to pick up that OE2, right? Now, so it's an OE2, but what if I were to say, we'll go to the gateway router and say router OSPF 1, default information originate always, let me change the metric type. So we're going to make it an E1. Let's see if it picks it up as an E1. There it is. So that's how you change the metric type if you want to. Keep in mind that the E1 is more desirable than an E2, right? Okay, so we change it to an E1. Let's go check the distribution router, and let's see, show IP route OSPF, and there you go. We've got that default route. So now for the true test, we've got a default route up to the gateway router. Can I now ping 209.165.201.1, and now I have full reachability. So, but down on this branch router, remember, we've got these external networks, and let me check here. If we come up to the gateway router, do I see those external networks? Do show IP route, whoops, OSPF. Am I catching all of those external networks? Well, they're externals, right? So if I was supposed to get those, they would be showing up as OE2s, correct? And that's right, they would be showing up as OE2s. So let's go ahead, let's drop down to that branch router. Let's say do show IP interface brief. Let's bring these guys into the fold. So we've got loopback 1, 2, 3, and 4. And let's do this. So let's say do show run interface loopback 1, loopback 2, 3, and 4. So we can see them all here. We've got, what do we have? A /25, a /25, /24, and a /24. So I'm going to redistribute these connected subnets into OSPF. However, if I just said redistribute connected, I would be redistributing all the connected routes. So let's do this. Let's do our own little prefix list here, and we're going to pick off only these routes. So IP prefix list, and I'm just going to say prefix list underscore LO for loopbacks. And we'll put a sequence number in here of 1, and we're going to say permit 172.31.64.0/25. So we're going to take that network statement and we're going to match that network statement. And let me cross-reference something here real quick on this gateway router, because I'm all of a sudden having a brain cramp. Yeah. All right, so we're good. All right, so we're going to match that /25. I'm going to pull this back up. We're going to say sequence number 2, permit, and we're going to catch the next one, which is the 172.31.64.128, whoops, 128/25. And then we're going to do a statement for sequence number 3. We're going to permit, and let me make sure I get this right here. It's going to be the 172.31.65.0/24. And then the last subnet, the last loopback address, will be sequence number 4. We're going to say permit, and he's going to be 172.31.127.0/24. So if I say do show IP prefix list, so there's my prefix list, PL_LO for prefix list for the loopbacks. We've got 4 entries. We're matching those networks exactly, right? Which should match those 4 loopback addresses. So now what do I need? Well, I need a route map to refer to those to that prefix list, right? And those prefix list statements. So I'm going to say route map, and I'll just call it RM_LO. And we are going to permit 10 in the first statement, and I'm going to match IP address. Now remember, I need to put in prefix list, right? Because if I don't put it in, it's going to match a named ACL, right? So I put prefix list in and then just PL_LO. And that's it. So do show route map. There's my route map. I'm only matching those 4 loopback interfaces by referencing the prefix list PL_L0. So now let's go ahead. Let's jump into router, OSPF 1, and we're going to say redistribute connected. And what do we have an opportunity to do here? We have opportunity to put a route map in. It's RM_LO. Now, I can set the metric on these guys. So if I said metric, and we'll set it to something 9999. We'll set it to 9999, so it'll be easy to see. And I can set the metric type again, right? So let's set the metric type to 1. We're going to have these guys come in as E1s. All right? Which means that the internal, or actually, here we'll do this. We'll say metric type 2, which is the default. So I'll hit enter, and it says, oh, I needed the subnets keyword. I apologize. Hold on. So redistribute connected subnets. There we go. So do show run. Let's make sure we only have one statement in here, section OSPF. Yep, so redistribute connected subnets. And actually, let's see what we've got. So I'm going to come all the way up here to the gateway router, where before we weren't seeing any of those 172 routes. I'm going to say show IP route OSPF. Now are we getting those E2 routes? Absolutely we are. Right? So this is absolutely perfect. Okay, so here are the routes that we're picking up. You can see that there is the metric that we set, and they're coming in as E2s. Now, remember, we set the metric to 9999, and we're redistributing those this way. So how is it then, and we'll talk about the difference between E1 and E2 right now. So how is it that coming this way, and I set the metric to 9999, how is it that going through this hop, this interface up to the gateway router, it's still 9999? Why is that? Because we know that that's an outgoing interface there, that's an outgoing interface there. So, and then the loopback, or actually we're redistributing these, sorry. So we've got 2 outgoing interfaces here, and it doesn't look as if the metric that was set has been adjusted at all. Do you see that? So it's interesting here that the metric hasn't changed. And this is the difference between E2 and E1. where E2 says, I don't care about any of the internal costs that may be added as I transit all of these, as I'm flooded into these different OSPF areas. I don't care. If we were to come over to the distribution router, what would you expect to see for the metric on those routes? Show IP route OSPF. You've got it, 9999. So again, there's no cost being added into the E2s onto the metric that we had set. Now, by default, OSPF on external routes, by default, the metric is 20. So when we do an E1, what does that tell us? That the additional cost is getting added in, right? The cost of the internal hops that it's taking. So let's do this. Let's see if that's a true statement. So E2 says, I don't care about any additional costs in here. When you redistribute me in, I'm just going to keep my default metric. Or if you've set the metric, I'm going to keep the metric of whatever it's set to. So let's go ahead. Let's pull that statement off. Let's say no redistribute connected metric 1, 2, 3, 4 subnets route map rm underscore lo. So if I say do show IP or do show run section OSPF, so that statement is, well, the redistribute connected is there, so we'll say no redistribute connected. So now we've pulled that statement off. So if I come back to the gateway router all the way at the top, we run that command again, all of those 172s are gone, right? Because we've pulled them out. So now let's redo this, and let's say redistribute connected subnets route map rm underscore lo, and let's set the metric to, we'll set it back to 9999, and now I'm going to say metric type 1, and I hit enter. So do show run section OSPF. So there's my statement, right? Redistribute connected metric 9999, metric type 1, subnets route map rm underscore lo. We come all the way back up to the top to the gateway router, show IP route OSPF. Aha! Now we've got a different scenario here, right? Take a look. So all 4 of those loopbacks, here's all these loopbacks, they are E1s, as you can see. But what is different? The original metric, which was set to 9999, has been changed. And it's been changed to 10,019. So the difference there is a difference of 20, correct? So the difference is 20. So we've got one outgoing interface here, and we have one outgoing interface here from the perspective of these routes being redistributed out. So let's see if this metric that it picked up, the difference of 20, what the metric is on these outgoing interfaces from where it was redistributed. So let's clear it. And again, the key factor here is that you can see the E1 route says, hey, I want to know what all the metrics are in the internal core network here when I'm making a decision as to what router I'm going to go to as my next hop. And so you can see it's going to router 2, right? And again, this is important because this is the difference is what they call hot potato, cold potato routing. So hot potato routing would be when you're looking at your E2. That's considered hot potato because I don't care how it gets out, just get it out of the network. Whereas E1 says, whoa, wait a minute, I want to know what every single outgoing interface is going to look like because I'm going to take into account all of the costs internally here through these different interfaces, right? So let me clear the screen there. And if I were to come down to the dist router as well, let's go ahead and do the same command down here, show IP route OSPF, and there you go. And you can see that an additional cost of 20 has been added to the distribution router. So if we were to come back to the branch router, and I were to say, do show IP OSPF interface Ethernet 00. What's the cost? Well, the auto cost reference bandwidth has not been set, and this is a 10 megabit per second interface. So 100,000, which is kilobits per second for the auto cost reference bandwidth for 100 meg, divided by 10,000 is going to give us 10. So the cost of this outgoing interface is 10. What's the cost of that outgoing interface? That's also going to be 10, and that is where we pick up our additional 20, because now the E1 metric type for these redistributed external routes is saying, hey, I care about the cost of these outgoing interfaces to get to these different routers. So now the distribution router saw it as 10099 as well. Was it 10099, I believe? What was 20 more? Or 19, sorry. 10019. Because again, 10, and then this is an Ethernet interface, and 10. That would be 20 going that way, right? And that's cheaper. That cost is better than going from here to here to here to here, right? Because we're looking at 10, 20, 30. So what would happen if I were to use one of the commands that we just saw from the discovery activity and say, that interface right there, let's change the OSPF cost on these two guys right here. So we know that the cost is 10 for both of those. What if I set it to 50? Would I be able to do some traffic engineering to say that the distribution router is no longer going to go that way? We're going to force the distribution router to come up this way to get to these routes. So let's confirm a couple things here. So let me go to the distro router, and let's say do trace, or I'm sorry, we'll just call it back here. Say trace to 172.31.64.1. And as you can see, what's my first hop? My first hop is to 24.2. That is router 2. Then I go to 16.25.5, which is the branch router. So let's see if we can manipulate this. So on the distro router, I'm going to go into interface, let's go into global config first. Let's go into interface Ethernet 0, and I totally drew over it there. It's got to be 01 though. Do show run interface Ethernet 01. Yep. Okay, so we'll go here. We're going to say IP OSPF cost 50. I'm going to step over to the HQ2 router, because remember, we want to do it the same on both sides. And I'm going to say IP OSPF cost. Oops, I'm not going to do it from privilege exec. Go into global config, interface, Ethernet 01. And I'm going to say IP OSPF cost 50. Right? So now I've changed the cost on that segment from 10. Right? It's no longer 10. Now it's 50. So this will be interesting. Let's see. Were we able to traffic engineer things so that the traffic will go, and let's actually quickly change colors here to blue. We'll do a blue. Is it going to go this direction, or is it going to go that direction? Right? Or I should say I'm from the wrong angle here. So from the distro router, is it going to go this way, or is it going to go that way? What do you think? So let's take a look. Let's do a Control C there. Let's go back to the distro router, and let's do a do show IP OSPF, or do show IP route OSPF. And who does it say the next hop is now for all of those E1 routes? 14.1. And look at the cost. It was 10 more. Because remember, it was 10,019 before, because we had 10, 20 being added to the default, the metric that we applied to it, which was 9999. But now we changed this to 50. So it's no longer an additional cost of 50, it's an additional cost that's going to get added in of 10 and 50 for a total of 60. So now that would be 10059. So is that metric going this direction better than 10029? It is not. So this is a better metric because, again, we're saying 10, 20, 30 is getting added, right? Because we're doing an E1. And so that is a shorter path. And in fact, it's getting a little messy in here. Let's clear this up. So again, this route is going to have a cost of what? 59. Or going that way, it's 10059. If we change the color here to red, going this way, the cost is now what? It's 10029 because we've got 10. Oops, sorry. Get rid of that guy there. We've got 10, 20, 30. Remember, these are I'm adding the 10s in. The cost is 10 of all those interfaces. So 10, 20, 30 gets added in. That gives us a metric of 10029 when added to the default, or I shouldn't say the default, to the custom metric that we gave it of 9999. So that is the difference between E2 and E1. Is E1 says, hey, I care, right? E2 says, I do not care about the cost of all of these internal links. So I'm just going to get put in here, and the default, again, would be 20, right? But again, we've made that an E1, so it's adding in the extra hop there. So this is the difference between E1 and E2, and this is a great way to do traffic engineering. Let's say that this is a circuit that we're paying for who knows, for whatever reason, and we don't want traffic to go this way. We pop in here and we say IP OSPF costs 50, boom, boom, and immediately the distro traffic is going to prefer the path out the other router, HQ1. So let's clear the screen. And I'll wrap up. We're going to wrap the activity up here. I apologize. I'm running long, but again, very important concepts to grasp, and especially if you're going to transition further in your studies, because this starts to become very important when you start to talk about, OSPF traffic engineering, the different LSA types. And so let's go ahead and say do trace, and let me trace again to 172.31.64.1. Where are we going to go? Look at that. We've got one extra hop, and why? We first go to 14.1, so we go from here to 14.1. Then we go to what should be, and it doesn't look like that segment's laid out, 123.2, which is going to be, oh yeah, okay, they have it right here, 123.2, which is router 2, and then we come down to the branch router, and all because we tweaked the OSPF cost here, forcing OSPF to say, you know what, with an additional cost of 50 here, this no longer is the best metric, the lowest metric. It's cheaper for me and a lower cost to go that way. All right, well, this is, again, fantastic activity here. Allowed us to really kind of branch out the conversation and take a look at the default information originate off of the gateway router. We got to take a look at some prefix list creation, a route map creation to get these externals into OSPF, and then we really went bananas by taking a look at the metric type, right? Why would you want to change it from an E2 to an E1? Well, we just saw a great case of when you would want to do that. Again, very flexible with respect to traffic engineering is OSPF. All right, so that wraps up challenge activity. Is this 5? Challenge activity 5. I will see you all next Monday.